Hello everyone, I am Krishna Mehta.
And I am Hachatrada.
In this presentation, we are going to discuss about circuit classification in reverse engineering. Objectives of these presentations are circuit classification, different types of circuits, and case study.
So here we can see the different type of the circuit classification. Here we can see that first is a closed circuit, second is open circuit, third is a series circuit, and the fourth is parallel circuit. Krishna will explain this.
So let's move on to the first one, that is the closed circuit. So what is closed circuit? The circuit in which there is a complete path for the electric current to flow is called a closed circuit. In the closed circuit, the energy can easily transfer from source to the load. Since it is a closed circuit, there is no broken path as shown in the figure. Now we move on to the second type, that is the open circuit. Since the word open suggests that there is no complete path for the electric current to flow. So since there is no complete path for the electric current, the energy cannot be transformed from the source to the load. Since there is an open circuit, there must be at least one broken path as shown in the figure. Third one is series circuit. So in series circuit, there are two or more components that are connected through by series as shown in the figure. But in series circuit, the current will remain same throughout all the components, but the voltage will be the total voltage of the circuit. Next.
So here we can see the parallel circuit. What is the parallel circuit and how does it work? In the same circuit, the charge separate the different branches so that there is a currently one branch over the other. However, taken as a whole, the total current value of the branches combined is equal to total current, and voltage will remain same. So here we can see the voltage of the two resistor will remain same in the parallel circuit. So now we will explore the case study of this reverse engineering. In this case, we will see how this classification of circuit we can use in reverse engineering. So here we will explore two case study, and the first is the reverse engineering in the floor mill machine, and the second is the reverse engineering in semiconductor industries. So in this reverse engineering, we will explore system level analysis and the product tear downs. So we will start the case study of the floor mill. Here we can see in this, we explore how circuit floor mill is working, which type of the features have in it, and the different type of the possible classification. And we can see in it what will be the process behind the floor mill and what is the role of circuit classification in this machine. So what is the introduction of this? So we have to put grain into hopper and start plugging. After the sensor will detect the grain, and the grain pass the motor, and the beater motor will start from getting command from circuit of floor mill. After the grain will drain and it will pass through a floor filter and it will go to container and store. When the container will full with the floor, the sensor will send the data to circuit and the machine will stop and the music will start. So here we can get acknowledgement, and when hopper will empty at the time sensor will detect there is no grain in hopper, then it will send the data to circuit and machine will stop automatically after 2 minutes. So analysis operation of the floor mill machinery. After adding grain into hopper, sensor detect the grain and send data to the circuit control. It seems that it's a work like a series circuit. Then circuit will start grain pass motor and beater. It's working like a parallel circuit. And the grain will start grinding grain and we will get a floor into the container When it is a full, sensor again read the data and send it to the circuit. Then circuit will off the machine. If in between the process, if we open the machine door, then there have one switch and it will free. It's a work like an open circuit, and the machine will stop automatically. And when hopper will empty, then also this process will do. So what is the function in the floor mill machine? Here we can see that in the circuit, a different function is like when we get data from a sensor, then it will react. When we add a grain, then it will pass voltage to the motor. And when grinding process done, then it will cut voltage supply to motors. And when click on the clean me button, then it will pass voltage to vacuum cleaner. So these have different functions like pass voltage, cut voltage, control voltage, and detect grain in etc. So here we can see the floor mill signal path. So here we can see the different path of the floor mill. Circuit to sensor, circuit to grain pass motor, circuit to beater motor, circuit to vacuum cleaner, circuit to music device. So what is the interconnection in the floor mill machinery? Here we can see that power supply is connected with the circuit because the different element of machine require different voltage. Circuit connect with different component is like a sensor, grain pass motor, beater motor, light, vacuum cleaner, etc. These all are interconnected with each other. So this all about the floor mill machinery. And Krishna will explain next topic, next class study.
So the next one, since the Heath has explained related to the analysis of the circuit, so the next will be differ of the product tear down. So what is a product tear down and how it is can be useful in case of reverse engineering? So product tear down means it is the simplest type of reverse engineering in the electronics arena, and the unit is simply disassembled. Since the figure is shown here, the below figure shows an Apple 8 GB iPod nano personal media player. It is partly toned down and exposed the internal boards and the ICs available in it. So the A part will explains the what type of extended temporary DRM has been used, since it has used many other products like Samsung S5 L8701 ARM core DSP flash controller. Next, they have used national step down for switching regulator, Apple Wolfson audio, and the last one is linear technology USB. So this type of the part combines and forms the one Apple 8 GB iPod. Next one, please. So since we are all using the cell phone, so it is the example of the cell phone. The figure shows the delayered 9-layer PCB from the cell phone. So here all the components on the board are categorized and they are selectively removed. If the board is multi-layered, it can be delayered, and the connection between all of the components can be identified and enter into a symmetric position. So since there are many layers in the cell phone, so through reverse engineering, we find one layer and what is there in it. Next.
So thank you very much.
Thank you, everyone.